In previous video, we have seen about some operations, logic operations in one stage of a arithmetic circuit. That is, in this table, it shows some operations that will be performed in an arithmetic circuit and the required operation to perform correctly. That is the logic operation that need to be performed in that arithmetic circuit. Okay, but first, when if S2 is equal to 0 means it performs the arithmetic operations. If S2 equal to 1 means it performs the logic operations. So we are making some changes to the existing arithmetic circuit to perform the different logic operations or XOR and NOT. But when this must change, that is S2 is made as 1, carry in is made as 0. After making these changes, what the circuit gives us output is these operations. Okay, currently the arithmetic circuit, after performing the operations, it gives the output like this. That is if combination is selection input is 1 0 0, it performs a transfer operation, but the required logic operation to be performed is OR. If the selection input is 1 0 1, it performs XOR, which is same as that of the required operation. And if 1 1 0 is the input selection input, then it performs equivalence, and but the required operation is AND operation. And if the selection inputs are 1 1 1, then it performs the NOT operation, and the required operation is also NOT. So the variation is in the in this step and this sequence. Okay, so these two outputs, it varies when compared to that of the required operation. So these two outputs need to be modified in such a way that it performs the or it gives the output of the logic operations. Okay, so how you got these outputs? By putting the inputs and calculating in this format, xi exclusive or yi, you will be getting some combinations, and those combinations will be defined as these operations. Okay, so what all are the different changes that need to be applied on the existing arithmetic circuit so that this transfer A can become changed to OR operation? So so from the first thing, you will be able to directly see that what you need to OR this function with the BI, or this function, that is AI will be ORed with BI to get the required operation, that is OR. Okay, so if the sequence is 1 0 0, then AI will be ORed with the BI. And next is like this sequence, that is if the sequences selection input is 1 1 0, what is the modification that need to be done? So currently what you are getting, that is xi exclusive or yi, which is AI exclusive OR. So AI exclusive or BI, you will be getting the output as AI BI plus AI complement BI. Now you can change the input, that is AI to AI plus KI. Okay, and then rewrite the above equation and see what is the output you are getting. So here, after substituting in place of AI as AI plus KI, you will be getting the result as AI BI, KI BI, AI complement, KI complement BI. So from this we can see that if I replace this KI with the BI complement, then what happens? These two terms get cancelled and resulting in AI BI. So from this we can infer that this in the arithmetic circuit, if I OR, that is, if I OR this A input with the Ki, so Ki finally I have made it as what? Bi. So if I OR this Ai with Bi, you will be able to get the AND operation as output. Okay, so two inputs, that is 100, 110, 100 and 110. They perform different operations when compared to the required logic operation. So in order to get the required operation, some modification will be done on the arithmetic circuit. In case of 100, what is the modification done? To this AI, BI will be ORed. And in case of 110, BI will be ORed with AI to get the output as AND operation. Okay, so so here see, XI input can be defined as AI. AI is the actual input. Together with this AI, you can OR BI. When it will be BI? When it is being ORed, BI is being ORed with AI, if the combination is 1, 0, 0. That is, in previous slide, you can see that if the combination of S2, S1, S0 is 1, 0, 0, then BI will be ORed with AI. So you can write the function as S2, S1 complement, S0 complement. S2, S1 complement, S0 complement BI plus, what is the other case? In this third row, S2, S1, S0 complement. So S2, S1, S0 complement. In that case, BI will be ORed. Okay, so these are the two things which will be done to modify the input Xi. Okay, so the then Yi will be like S0 BI and S1 BI complement. In case of Yi, there is no change when compared to that of the arithmetic circuit. So what is the function, or what is the function that is used in the arithmetic circuit? Same function we are using here also in case of input Yi. Then in case of Zi, there is a change. Previously it was like a S signet, that is here you can see over here. C in, carry in is given as input to the C. Okay, that is, it can be either 0 or 1. Here in case of logic operation, what we have defined here, that is carry in, input carriages will be defined as 0 to implement the logic operation. So Ci will be equal to 0. Okay, so for that, if S2 is equal to 0, then Ci can be equal to 1. If S2 is equal to 1, then Ci will be equal to 0. So what is the observation from there? You can infer that it is the complement. So here Zi can be defined as S2 complement Ci. S2 complement Ci. So keeping these functions in mind, you can design the gate. You can design the circuit for the arithmetic and logic operations. So here you can just take this example, take this diagram and see only this one full ladder circuit. Okay, so here first you consider the input xi. Okay, xi. So xi, the function is like ai plus ai. First is ai. So here all the terms they are combined using this plus symbol, isn't it? So OR gate will be used. So here an OR gate is being used, and then AI is given as an input to the OR gate. So AI. So here AI is given as an input to this OR gate. Then what? BI is also given as an input, but it is in a combination, that is S2, S1 complement, S0 complement BI. That is here in order it performs the AND operation. So an AND gate will be included. Two AND gates are required to represent these two terms, and the input to these terms also based on this terms, the inputs will be fixed. So here two AND gates are being included. So one will be taking the input as, one AND gate will be taking the input as BI alone. So together with that BI, which all input S2, S1 complement, S0 complement. So here selection inputs S2, S1, S0 is there. So S2 complement will be given as an input to the to that AND gate. Okay, so S2 complement, S2, S1 complement, S0, these things will be given as these things will be combined together and given as an input to the AND gate. So for that purpose, again we are making use of an AND gate over here, and this AND gate, it takes what? S2 complement, not S2, S2 alone, S2, S1 complement and S0 complement. So S2 will be taken, then S1 complement. So S1 complement means it is fed to this NOT gate, and that output will be given as another input. Then again S0 complement, again NOT gate, it will be given as an input to the NOT gate and will be given as a and will be fed to this AND gate. Okay, so S2, S1 complement, S0 complement. Okay, to this AND gate. And from this AND gate, it will be given as an input to the another one AND gate where the BI input is given. Okay, so that is the second term. In a third term, it is S2, S1, S0 complement. S2, S1. For that also, we are making use of this AND gate to combine S2, S1 and S0, S2, S1 and S0 complement. So here S2, it is joined over here, S1, and for S0 complement, see, input that is after the NOT gate only that thing is taken. Output of that NOT gate is taken and fed to this AND gate, and that output will be fed to the second AND gate where BI complement is given. So BI complement is, BI will be given as an input to NOT gate, and then it will be given as an input to the AND gate. Okay, so this is the arrangement of the inputs variable xi. Same replica will be managed for other full adders also. Next is like yi. So for yi, what happens?